Is that recording? Yes, all right. All right, so, sorry. A line segment has a distinct start and a distinct end. A ray has a distinct starting point but no end. And then a line has no end in each direction. So this would be the line that passes through points A and B. So our notation for that one would be AB with a line over it. You can show it sometimes like this, but it's sufficient to show it like this. And this is a line. So the difference between a line array and a line segment is a line segment has two distinct ends. Most geometry, like a triangle, is made up of 3 line segments. A ray has a distinct starting point but no end, and a line just continues in both directions. Angle vocabulary now. So we have to be able to identify the difference between a vertex, a side, and an angle. So our vertex is a corner. So a vertex means a corner. This is a corner. So we have the vertex A. And we could describe it using the letters that are given here. So it's the vertex at A. The sides, well, we've got 2 rays here. We've got one side AB, and we have another side AC. And these are rays. So this would be the vertex, we have one side AB, and we have a second side AC, made up of 2 rays. What about the angle? Now, one of the problems with angles is how many angles are shown here? What do you mean by 2? He's absolutely right. So we have 2 angles. Obviously, this angle is usually the one we're going to be talking about, but there's also this reflex angle, or the exterior angle. So at vertex A, there's 2 angles. Typically, we assume that it's the interior angle. And to describe an angle, we use a traversal of 3 points. So we can't just say A. What we're going to show in order to get the angle is we do a traversal. So start at B, move to A, and then move to C. This would give us the interior angle BAC. You could start at C, call it CAB. These two would be the same angle. So our second angle would be CAB, and these are the same angle. So these 2 angles are the same, so we would say that they're congruent. You can turn the little triangle upside down if you want the exterior angle. So we could also have the exterior angle BAC, and that would mean the exterior angle at vertex A.
But isn't BAC the same as the interior angle?
BAC is the interior angle, and there's also an exterior angle at BAC, and that's why I've turned that little symbol upside down to imply it's the exterior angle I wanted this time. So this would be the interior angle. At vertex A, and this would be the exterior angle. Okay, have a go at naming what the vertex is, the sides are, and the angles for yourselves. Have a go at naming what the vertex, the sides, and the angle are. Write them down in your notes. Matt, take out your notebook, write it down. You could do a CAB as well. So that means it's a different traversal with the same angle as the first. Move a little quicker. Don't draw lines by shading up and down, back and forth. One single circle. S is included in the interior and the region. So it would just be D3R. Okay, let's look at our answers. So where is the vertex? Q. What are the two sides?
RQP.
So QP
Oh, and QR.
and QR, and they're raised. What about the interior angle?
RQP.
I always like to put them in order, but RQP would be correct. I would call it PQR. Does the point S lie in the interior or exterior of the angle? In the interior. So it's in the interior space. Okay, so some key vocabulary there for angles. Vertex, side, angle, how to describe them using notations, and then line, segment, ray, and line. Let's have a look at using a protractor. What is the measurement of this first angle? So in order to use the protractor, if you notice we have, starting here, we have 0, we go around in this direction up to 180, but also we start with 0 here. So you have to be careful whether you're using interior or the exterior markings of this device. We start by lining up one line, this line here, on your line, and then we move this point here to where the angle occurs to the vertex. And then from the second line that comes out, we can measure in this direction. So in this one, we're starting here, we scroll around to 20 there, and then 5 more. So this one is 25 degrees. What do we think the second one is?
75.
This one's 75. How about this one?
No.
30.
It's 30.
Notice we start here and we scroll in this direction. This one's 30.
Other side.
What about this one?
75. Oh,
115.
Got to be careful. We're starting here. We're scrolling round in this direction. There's 110. 115. Look, there's 110. There's 110. So the angle is less than 120. So it's between 110 and 120. This is at 115. Okay, let me do this one as an example. This one's a little tricky. So we need to work out the angle here. We need to work out this angle. The way we do it is we're going to start by finding angle A, and then we're going to find angle B. So the angle that we want is given by B minus A. So the angle B, we start at 0, we go around, that's 100. The angle A, we start at 0, we go around, that's 20. So the angle C is how much? 80 degrees. All right, try these ones for yourself. Doesn't matter what the school mark is saying.
What is that? What is that?
Theta.
What?
Theta. Angles often use Greek letters. This is our favorite letter for an angle, is theta. Our next most popular one would be alpha and beta. We often use these 3 letters. You know, like for instance with With variables, we start with x and then we have y. X is the independent y. With constants, we have a, b, c. Functions f, g, h. Integers n. Well, for angles, we like to use theta, alpha, beta as our preferred letters for angles. So this one, we can measure it in two ways. We can say that theta is equal to 90 minus 40, which equals 50. But I can also measure it round from the other direction. I could also measure it round from the other direction. I can go up to, from here to 140 and then subtract 90. I'm still going to get 50. It wouldn't matter which side we do it from. So here on this one, I'm going to go round from here 125, and then I'm going to go around from here in this direction like this. This one's 35, 90 degrees. We got an AXL on that. You'll practice that. All right. Complementary. So we've got a few more bits of vocabulary. Make sure you take down the vocabulary in bold. Write this one down. Write down the definition. Complementary angles have measures that add up to 90 degrees. Write that down. Make it stand out. And we got 3 words. 4. Complementary angles are angles that add up to 90 degrees. Which 2 angles are complementary? There is no angle P.
Q and R.
There is no angle Q. There is no angle R.
PTS and QTS.
P, T, oh, PTS, and which one?
QTS.
QTS. Let me draw it like this. These 2 angles are 90 degrees. Oh, sorry, these 2 angles are complementary. They'll add up to 90.
Does it have to be more than one angle?
It needs to be 2. Okay, copy down the definition for supplementary. Copy down the definition for supplementary.
Makes sense. No.
Which 2 angles are supplementary?
It's QTR.
PTQ
PTQ,
and QTR.
QTR. Is there another pair?
Could it be more than 2?
PTS.
PTS, STR. These are both pairs of supplementary angles. Adjacent. Adjacent. Copy down the definition for adjacent. It's a bit more complicated. Adjacent angles share a vertex and a side, but no interior points.
PTS plus QTS equals 90.
Write down your definition for adjacent. So adjacent angles share a vertex and a side, but no interior points. Can we see an example of two adjacent angles here?
QTR.
QTR. Another one? QTP. That'll do. These are adjacent. How have I spelled adjacent then? Adjacent. Which two angles are not adjacent? Well, not adjacent would be PTS and QTR. PTS and QTR. These are not adjacent. Why not?
You said that it's adjacent. You said QTR is adjacent.
QTR, QTP. QTR, QTP. These are adjacent.
Yeah, but they're not adjacent.
Not with
PTS is not adjacent to QTR. Why not? We are looking at this angle and this angle. They share a vertex. What? They don't share a side. They don't share a side. Means they're not adjacent. Okay, what about QTR? Oh, sorry. What about QTP and QTS? Are these adjacent?
No.
Why not? They share a vertex. They both have this vertex. They share a side. They both have this side, QT. Why are they not adjacent? Because they share these interior points. Adjacent angles can't share the same interior points. They share all of the interior points here. Okay, vertical angles. Write down our definition this time. Vertical angles are angles formed opposite each other when two lines intersect. Vertical angles are congruent, which means they have the same angle measure. Okay, let's have a look. So Vertical angles are made when two lines intersect. So this line and this line intersect, making a vertical angle. So this means that this angle here and this angle here are vertical angles. So one example of vertical angles would be FGE. That's this one, FGE. And BGC. Vertical angles are congruent. BG. Sorry, I can't draw my G. BGC. So these two angles are vertical angles. They are congruent, which means they have the same angle measure.
There's another one, BGF and CGE.
BGF and CGE. Yeah. So these two lines intersect and they create two sets of congruent or vertical angles. So this angle here and this angle here, these are congruent to each other because they're vertical angles. This diagram, there's a bunch of them. You can make hundreds. Well, not hundreds, you can make quite a few. All right. Have a go at this question. Which angle is supplementary to angle 2? What do we think? What's our answer?
43.
Which angle is supplementary to angle 2? No?
Is it what angle?
In the question,
5.
how many angles are asked for in the question? How do we know it's only one angle? It's because it's angle. Which angle is supplementary to angle 2? Nadeem. Angle 5. Why? This angle is 90 degrees, given. Why is that also 90? Well, how do we know that? We can say that angle 2 equals 90. This is given. We can say that angle 2 is congruent to angle 5. Why? How do we know that? How do you know it's 90? Because these are vertical angles, which implies that they're congruent. This implies angle 2 equals 90. Therefore, angle 5 is 90. Therefore, angle 2 plus angle 5 equals 180. So these are supplementary. So angle 2 is 90, that's given. Angle 2 is vertical to angle 5, meaning it's congruent, which means angle 5 is 90, which means the two of them are supplementary. Which angles are supplementary to each other from the list given? Here it gets a bit tricky. So use your pen to help you. Find where is this angle, FGH. So draw the dots, FHG, that one. EDK, so EDK, this one. Are these supplementary? We don't know. Not enough information to tell us. So we'll say no. KDL. KDL. JAE. JAE. We don't know. Oh, sorry, let's clear first. JAE. Where's that one again? JAE. Is it with FHG? FHG. We don't know. EAH. Where's that one? EAH. HAI. HAI. Ooh. Are these ones supplementary?
Yeah.
Yes.
Why?
It also covers
All the angles on a straight line add up to 180. So all the angles sum on a straight line add up to 180. So it's this one. All right, you can start your IXLs now.